There is a sea on the moon. It has no water. It has never had water. It is a vast, dark plain of ancient solidified lava spread across the surface of the moon more than 3 billion years ago, when the lunar interior was still hot enough to produce volcanic floods that pooled in the great impact basins of the early moon. The early astronomers who looked at the moon through their first telescopes, seeing these dark, smooth expanses against the brighter cratered highlands, named them Maria, the Latin word for seas. Mare Tranquillitatis, the Sea of Tranquility; Mare Serenitatis, the Sea of Serenity; Mare Imbrium, the Sea of Showers; Oceanus Procellarum, the Ocean of Storms. The names are wrong about the water, but right about the peace. There is something deeply tranquil about the moon's dark plains, so smooth and ancient and still. On July 20th, 1969, 2 human beings stood in the Sea of Tranquility. Neil Armstrong and Buzz Aldrin became the first members of any species, as far as we know, to stand on a world other than the one they were born on. The site they chose for the landing was chosen partly for its flatness and safety, and partly for a reason that is easy to overlook: its name. The Sea of Tranquility felt like the right place for humanity's first careful step beyond its own world. Tonight, the moons of the solar system are your companions. From our own familiar moon to the bizarre and extraordinary satellites orbiting Jupiter and Saturn and Neptune and Pluto, each one has a story. Each one is a world, and the stories they tell are among the most remarkable in all of planetary science. Take a slow, deep breath. Let the quietness of the Sea of Tranquility settle over the room you are in. The moon is out there tonight, somewhere in the sky, reflecting the light of the sun. Its surface has not changed significantly in 3 billion years. It is waiting, patient and ancient, exactly as it has always been. The moon is large for a satellite of a rocky planet. Its diameter is about 3,474 kilometers, about 27% of Earth's diameter. The ratio of the moon's mass to Earth's mass is about 1 to 81, making the moon by far the most massive satellite relative to its host planet in the inner solar system. Mars's moons are tiny captured asteroids. Venus and Mercury have no moons at all. The moon is so large relative to Earth that the two bodies are sometimes described as a double planet system. The origin of the moon is one of the most remarkable stories in the history of the solar system. The leading hypothesis, the giant impact hypothesis, proposes that approximately 4.5 billion years ago, when the solar system was less than 100 million years old, a Mars-sized protoplanet collided with the early Earth in an oblique impact. The impactor, sometimes called Theia, struck the proto-Earth at an angle, not head-on, but at a glancing blow. The collision was catastrophic. Both bodies were melted and partially vaporized. The debris from the collision, composed of material from both Theia and the outer mantle of the proto-Earth, was ejected into orbit around the Earth in a disk of molten rock and vapor. Within this disk, over a period of perhaps 100 to 1,000 years, the material accumulated into the moon. The giant impact hypothesis is supported by several lines of evidence. The moon's composition is remarkably similar to the Earth's outer mantle, as would be expected if the moon formed from material ejected from Earth's outer layers. The moon is depleted in iron and other dense metals compared to Earth as a whole, consistent with its formation from the outer mantle rather than the iron-rich core. And isotopic analyses of lunar rocks show a very close match with Earth's composition, so close that the Moon and Earth appear to have formed from the same well-mixed reservoir of material. The giant impact would have been sufficient to homogenize the compositions of both bodies. The newly formed Moon was an extraordinary sight from the early Earth, a glowing ball of molten rock orbiting at perhaps 1/10 its current distance, appearing enormous in the sky, its surface covered with a magma ocean hundreds of kilometers deep. Over millions of years, the magma ocean cooled, crystallizing from the bottom up. The lighter minerals floated to the surface and formed the ancient, pale, heavily cratered highland crust. The heavier minerals sank and formed the mantle. The heat from the interior, residual from formation and supplemented by the decay of radioactive isotopes, sustained partial melting in the interior for another billion years, producing the volcanic floods that filled the impact basins and created the Dark Maria. The tidal lock between the Moon and Earth is one of the defining features of the Earth-Moon system. The Moon rotates on its axis in exactly the same time it takes to orbit Earth, approximately 27.3 days. This is not a coincidence, it is the outcome of tidal friction. Early in the Moon's history, it rotated faster than it orbited, so different faces were presented to Earth over time. But the tidal bulge that Earth's gravity raised in the solid body of the Moon was dragged slightly ahead of the Earth-Moon line by the Moon's rotation, and the gravitational force on this asymmetric bulge progressively slowed the Moon's rotation until it was synchronized with the orbital period. This process took hundreds of millions of years to complete. As a result of tidal locking, the Moon always presents the same face toward Earth. The near side is the familiar face of the full Moon, the Dark Maria, the bright highland regions, the great crater Tycho with its ray system, the Sea of Tranquility where Apollo 11 landed. The far side, which was completely unknown until the Soviet Luna 3 spacecraft photographed it in 1959, is very different. It has very few Maria and is dominated by the bright, heavily cratered highland terrain. The reason for this asymmetry is still debated, but one explanation invokes differences in crustal thickness. The far side has a thicker crust, which prevented the ancient volcanic lava from reaching the surface and filling the impact basins. The Moon is not stationary in its orbit. Every year, it moves about 3.8 centimeters farther from Earth, driven by the same tidal friction that slowed its rotation. The energy stolen from Earth's rotation by the tidal forces is transferred to the Moon's orbital energy, raising its orbit. As a consequence, Earth's rotation is slowly slowing. A day on Earth is getting longer by about 2.4 milliseconds per century. Billions of years ago, when the Moon was much closer, a day on Earth was only about 6 hours long. Fossil records of tidal rhythms in ancient stromatolites show that 600 million years ago a year contained about 400 days, consistent with a shorter day. In the far future, if Earth survives the Sun's red giant phase, the Earth-Moon system will eventually become doubly tidally locked, with Earth rotating once per month and the Moon orbiting once per month, each keeping the same face toward the other. The tidal forces exerted by the Moon are not just philosophical curiosities, they are among the most important physical phenomena affecting life on Earth. The ocean tides, driven primarily by the moon and secondarily by the sun, have shaped coastal ecosystems throughout the history of life. The intertidal zone, the region between high and low tide, is one of the most biologically productive environments on Earth, exposed to air twice daily and submerged twice daily, creating conditions that some evolutionary biologists believe were critical for the transition of life from sea to land. The tidal forces may also play a role in driving plate tectonics by creating stress in Earth's interior. Some models suggest that the presence of the moon has been important for the stability of Earth's climate over geological timescales by stabilizing the axial tilt of Earth against the chaotic perturbations that would otherwise cause large variations in the obliquity. Io is the most volcanically active body in the solar system. It is Jupiter's innermost large moon, slightly larger than Earth's moon and approximately the same density. Its surface is covered with sulfur and sulfur dioxide in a variety of colors, ranging from white and yellow to red and orange and black, giving it an appearance that has been compared to a pizza. At any given moment, more than 400 active volcanic centers are erupting on Io's surface, spewing molten silicate rock, sulfur, and sulfur dioxide gas into the vacuum of space in fountains and plumes that can reach hundreds of kilometers in height. The source of Io's extraordinary volcanic activity is not its own radioactive decay, as is the case for the Earth's geological activity, but tidal heating. Io is embedded in the intense gravitational field of Jupiter and is also in resonance with the other Galilean moons, Europa and Ganymede. This orbital resonance prevents Io from settling into a circular orbit. Its orbit is kept slightly elliptical by the gravitational perturbations of Europa and Ganymede. As Io moves through its elliptical orbit, the gravitational force of Jupiter on it varies, and this variation flexes and kneads Io's interior like a hand squeezing a rubber ball. The friction generated by this constant flexing heats Io's interior to the point where it is essentially entirely molten, and the molten material continuously erupts onto the surface. The volcano Pele on the Io was one of the first active volcanoes discovered beyond Earth, identified from the Voyager 1 flyby in 1979. Its plume reaches about 300 kilometers into space, and the fallout from the plume creates a distinctive ring-shaped deposit of sulfur and sulfur dioxide on the surface with a radius of about 600 kilometers, visible from the Voyager and Galileo spacecraft as a large red ring. Since Pele's discovery, dozens of other active volcanic features have been identified on Io, including lava lakes, calderas, and lava flows of extraordinary scale. The lava erupted by Io's volcanoes is among the hottest in the solar system, reaching temperatures of up to 1600 degrees Celsius, comparable to the hottest lavas erupted on early Earth, and suggesting that Io's magma composition is more ultramafic than typical terrestrial lavas. Let your breathing be slow and easy. Io is out there right now, orbiting Jupiter, its volcanoes continuously erupting in the darkness of the outer solar system. Nothing lives there, nothing could live there. But it is beautiful in its ferocity, a world that is never cooled, never quieted, never stopped erupting in the billions of years since it formed. Europa is one of the most scientifically compelling objects in the solar system. It is Jupiter's fourth largest moon, somewhat smaller than Earth's moon, and its surface is one of the smoothest in the solar system, a vast expanse of ice. Almost perfectly flat, crisscrossed with a network of dark, linear features that give it the appearance of a cracked eggshell. This icy surface is the roof of a vast ocean of liquid water that lies beneath. The ocean is estimated to be 60 to 150 kilometers deep, containing perhaps twice as much liquid water as all of Earth's oceans combined. Kept liquid by the same tidal heating from Jupiter that keeps Io volcanic. The evidence for Europa's subsurface ocean is strong and multifaceted. The magnetic field measurements from the Galileo spacecraft showed that Europa has an induced magnetic field that varies with Jupiter's rotating magnetic field, consistent with the presence of a conducting fluid layer, almost certainly a salty ocean, beneath the icy surface. The surface ice shows features consistent with being a relatively thin crust floating on a liquid, regions where the ice has broken into plates and rafted apart, double ridges running for thousands of kilometers that may be formed by tidal squeezing of the crust, and reddish-brown material coloring the cracks that may be salts from the underlying ocean deposited on the surface by upwelling. Where there is liquid water, there may be life. Europa's ocean has existed for billions of years, long enough for life to have originated and evolved if the chemical conditions are right. The energy driving the tidal heating of Europa also drives seafloor volcanism at the ocean floor, potentially creating hydrothermal vents similar to those on Earth's ocean floors, where rich communities of life exist independent of sunlight. The Europa Clipper mission, launched by NASA in October 2024, is specifically designed to study Europa's ocean and evaluate its habitability potential, conducting dozens of close flybys of Europa while remaining in orbit around Jupiter to study the moon's magnetic field, ice shell, and surface composition in detail. Ganymede is the largest moon in the solar system, larger than the planet Mercury and about 1.5 times the size of Earth's moon. It orbits Jupiter at a distance of about 1 million kilometers and is the only moon in the solar system known to have its own magnetic field, generated by convection in its iron core. This intrinsic magnetic field creates a small magnetosphere within Jupiter's much larger one, producing auroras at Ganymede's poles that have been observed by the Hubble Space Telescope. Ganymede also almost certainly has a subsurface ocean of liquid water, sandwiched between layers of ice at depth, making it another of Jupiter's ocean worlds. Ganymede's surface is divided into two distinct terrain types: older, darker, heavily cratered regions, and younger, brighter, grooved terrain that is less densely cratered and shows evidence of tectonic activity early in the moon's history. The grooved terrain formed when the ice crust was stretched and fractured by tidal forces in the past, producing rift-like structures that extend for thousands of kilometers. The oldest terrain on Ganymede, like that on Callisto, dates back to the early period of heavy bombardment more than 3.9 billion years ago. Callisto is the outermost of Jupiter's 4 large Galilean moons and has the most heavily cratered surface in the solar system. Unlike its 3 inner siblings, Callisto appears to have undergone very little internal differentiation it is not separated into distinct layers of core, mantle, and crust, but is instead a fairly uniform mixture of rock and ice throughout. This may be because Callisto is far enough from Jupiter that tidal heating is insufficient to melt and differentiate its interior. Its surface is a record of bombardment stretching back 4 billion years, a geological archive of the early solar system's violent history. The largest impact structure on Callisto, Valhalla, is a multi-ring basin about 3,800 kilometers across, one of the largest impact basins in the solar system. It was formed when a very large object struck Callisto, and the impact caused the icy crust to flow outward in concentric rings, like the ripples from a stone dropped into a pool before freezing in place. Valhalla's ring structures extend for nearly 2,000 kilometers from the central impact zone, a permanent record of a single catastrophic moment more than 3 billion years ago. Titan, Saturn's largest moon, is one of the most Earth-like places in the solar system, despite being nothing like Earth in its chemistry. It has a thick, opaque atmosphere of nitrogen with a surface pressure about 1.5 times Earth's, making it the only moon in the solar system with a substantial atmosphere. It has weather, clouds of methane form in the atmosphere, and rain methane onto the surface. It has rivers of liquid methane cutting channels through the frozen water ice bedrock. It has lakes and seas of liquid methane and ethane at its polar regions. Ligaea Mare, one of the largest methane lakes near Titan's North Pole, is roughly the size of Lake Huron on Earth. The Cassini spacecraft's Huygens probe parachuted through Titan's atmosphere and landed on its surface on January 14, 2005, becoming the most distant landing of a spacecraft ever achieved at that time. During its 2.5-hour descent, Huygens transmitted images of an orange-tinged sky, rounded pebbles of water ice on what appeared to be a dry riverbed, and a flat horizon stretching to the edge of a plain. It was a landscape that resembled Earth in a profoundly alien way, the same processes of erosion, transport, and deposition operating on a different chemistry in an environment 10 degrees Kelvin above absolute zero. Titan's atmosphere is rich in organic chemistry. The ultraviolet radiation from the sun and the charged particles in Saturn's magnetosphere drive complex photochemical reactions in the upper atmosphere, producing a thick orange haze of organic molecules called tholins, laboratory analogs of which have been shown to produce amino acids when treated with liquid water. Titan's surface may be covered with a layer of these organic molecules hundreds of meters thick, delivered over billions of years of atmospheric chemistry. If liquid water were ever to reach Titan's surface, for instance through a large asteroid or comet impact, the resulting mixture of liquid water and organic material would be a laboratory for prebiotic chemistry. Enceladus is one of the most extraordinary discoveries of the Cassini mission to Saturn. It is a small moon, only about 500 kilometers in diameter, that would appear unremarkable from a distance, a bright white icy sphere. But in 2005, Cassini discovered that Enceladus is actively venting material into space from its southern polar region through a series of long, parallel cracks in the ice called tiger stripes. These cracks, about 500 kilometers long and spaced about 35 kilometers apart, are warmer than the surrounding terrain by tens of degrees, heated by the tidal energy that also powers the venting. The plumes rising from the tiger stripes consist primarily of water vapor and ice particles, but also contain carbon dioxide, methane, hydrogen, and complex organic molecules including compounds of carbon, hydrogen, nitrogen, and oxygen. The hydrogen in the plumes is particularly significant. It is consistent with being produced by the reaction of hot water with rock in hydrothermal systems at the floor of Enceladus's subsurface ocean, a process called serpentinization. This is the same process that drives hydrothermal vents on Earth's ocean floors, which are among the most biologically productive environments on Earth independent of sunlight. Enceladus's plumes feed Saturn's E-ring, the broad, diffuse outer ring that extends throughout a large portion of the Saturn system, visible as a faint blue tinged band in enhanced images from Cassini. The particles vented from Enceladus's tiger stripes spiral outward from the moon and populate the E-ring, making Enceladus the source of one of Saturn's most visible ring structures. It is the only known case of a moon actively maintaining one of its planet's rings through ongoing geological activity. Let your breathing settle into the quiet of a deep, dark ocean. The ocean of Enceladus, dark and liquid, heated by the tides of Saturn, is out there right now beneath its icy crust. Nothing has yet confirmed that it harbors life, but the conditions required for life as we know it, liquid water, chemical energy from hydrothermal reactions, organic molecules, are all present. Enceladus is one of the most scientifically urgent targets in the search for life beyond Earth. Mimas is perhaps the most visually dramatic of Saturn's moons because of Herschel, a crater covering nearly a third of the moon's diameter. If the impact that created Herschel had been much larger, it would have shattered Mimas entirely. Herschel has a central peak about 6 kilometers high, raised by the rebound of the crater floor after the impact. The resemblance of Mimas to the Death Star of the Star Wars films was noted when Voyager 1 photographed it in 1980 and has made Mimas perhaps the most famous of Saturn's small inner moons. Mimas also has an unusual rotation. It wobbles as it orbits Saturn in a way that suggests its interior is not uniform, perhaps harboring a hidden subsurface ocean or having an irregularly shaped core. The wobble, called a libration, was detected in Cassini observations and cannot be explained by a simple uniform interior. If Mimas does have a hidden ocean, it would be one of the smallest bodies in the solar system known to maintain liquid water, making it even more remarkable. Iapetus is one of the strangest moons in the solar system, covered with a profound two-toned surface. One hemisphere is as dark as coal, one of the darkest surfaces in the solar system, while the other is almost as bright as fresh snow. This extraordinary contrast was first noted by the Italian astronomer Giovanni Cassini in 1671, who found that Iapetus was visible only at certain points in its orbit, leading him to correctly infer that it had differently colored hemispheres. The explanation for the two-tone surface was not established until Cassini's spacecraft observations revealed that the dark material is a thin layer of reddish-dark material deposited from outside, from the dust of outer irregular satellites spiraling inward, which accumulates on the leading hemisphere of Iapetus as it orbits. The dark material absorbs sunlight, heats the surface, drives water ice away from the dark regions into the cold, bright, trailing hemisphere, amplifying the original contrast through a thermal segregation process. Iapetus also has one of the most remarkable features on any moon, a ridge running exactly along its equator for about 1,300 kilometers, reaching heights of 13 kilometers in some places, taller than any mountain on Earth. The origin of this equatorial ridge is not fully understood. It may be a remnant of a ring system that Iapetus once had and that gradually collapsed onto its equator as the ring particles settled, or it may be produced by tectonic stress from the moon's past rapid rotation, slowing to its current tidally locked state. Hyperion is a moon of Saturn with a shape unlike any other major moon. It is irregular, roughly the shape of a flattened potato, about 360 by 266 by 205 kilometers in its three principal dimensions. More remarkably, Hyperion tumbles chaotically in its orbit, rotating in a way that is genuinely unpredictable over timescales of weeks. Its rotation is chaotic because its orbit is in a 4-3 resonance with Titan, the perturbations from which continuously change the direction and rate of Hyperion's spin. This makes Hyperion one of the few solar system bodies definitively known to exhibit chaotic rotation. Hyperion's surface resembles a bath sponge at large scales. It is covered with deep, sharply defined pits separated by narrow ridges, giving it an extraordinarily porous appearance. The density of Hyperion is so low, only about 544 kilograms per cubic meter, less than water ice, that it is estimated to be about 40% empty space. The material of Hyperion appears to be a fluffy, porous aggregate rather than a solid body, accounting for both its low density and its unusual cratering pattern, in which impactors tend to leave deep, sharp pits rather than the shallow, raised rim craters of denser, more rigid bodies. Miranda, the smallest and innermost of Uranus's 5 large moons, has the most dramatic and varied topography of any moon in the solar system relative to its size. It was photographed by Voyager 2 during the spacecraft's flyby of Uranus in 1986, and the images were deeply puzzling. Miranda has enormous rectangular regions called coronae, trapezoidal features of concentric ridges that appear to be completely different in structure from the surrounding terrain. One of the coronae, Inverness Corona, is bounded on one side by Verona Rupes, a cliff approximately 20 kilometers high, perhaps the tallest cliff in the solar system. An object dropped from the top of Verona Rupes on Miranda, where the surface gravity is only 0.08% of Earth's, would take about 12 minutes to fall to the bottom. The explanation for Miranda's extraordinary geology is debated. One early idea was that Miranda had been shattered by a large impact and reassembled itself, with the different terrain types representing fragments of different original layers that were mixed during reassembly. A more favored current explanation is that Miranda has experienced episodes of partial interior heating, perhaps through the same tidal resonances that heat Io and Enceladus, which produced upwellings of warmer ice in certain regions, creating the coronae through a process similar to, but much more extreme than the diapires that produce geological features on Earth and other bodies. Triton is Neptune's largest moon and one of the most unusual objects in the outer solar system. It orbits Neptune in the retrograde direction, opposite to Neptune's rotation and to the orbital direction of the other moons, an almost certain indication that it was captured from the Kuiper belt rather than forming in place alongside Neptune. A moon that forms in a protoplanetary disk around its planet will always orbit in the same direction as the planet's rotation. A retrograde orbit requires an external origin. Triton is therefore almost certainly a Kuiper belt object, a cousin of Pluto, captured into orbit around Neptune in the distant past. The capture of Triton was catastrophic for any moons that Neptune had before. The gravitational disturbances caused by a retrograde intruder would have ejected or destroyed the original satellite system. The irregular, chaotic collection of small retrograde moons that Neptune still has today may be the debris of this ancient catastrophe. Triton's retrograde orbit means that tidal forces are decelerating it rather than accelerating it. It is slowly spiraling inward. In approximately 3.6 billion years, it will spiral close enough to Neptune that it will be torn apart by tidal forces and will form a new ring system around Neptune, perhaps as spectacular as Saturn's. Triton is also geologically active. When Voyager 2 flew past Neptune and Triton in August 1989, it discovered active geysers on Triton's surface, plumes of dark material rising several kilometers and being blown downwind by the thin nitrogen atmosphere. These geysers are not driven by internal heat like Io's volcanoes or Enceladus's plumes, but by solar heating. Sunlight penetrates the transparent nitrogen ice of Triton's surface and heats the darker material below, which vaporizes the nitrogen above it and forces jets of gas and entrained dark material through the ice to the surface. Triton's surface temperature is approximately minus 235 degrees Celsius, one of the coldest surfaces measured in the solar system, close to absolute zero. It is covered with nitrogen and methane ices, with a pinkish tint from organic compounds produced by the action of radiation on the surface ices. The terrain includes a large southern polar cap of nitrogen ice and a remarkable feature called the Cantaloupe Terrain, a region of irregular, roughly circular depressions that resemble the surface of a cantaloupe melon and has no equivalent on any other body in the solar system. Charon is Pluto's largest moon and the partner in one of the most remarkable binary systems in the solar system. With a diameter of about 1,200 kilometers, Charon is more than half the diameter of Pluto itself. The mass ratio between the two bodies means that their common center of mass, the point around which both orbit, lies in the space between them rather than inside either body. Both Pluto and Charon are tidally locked to each other, each always presenting the same face to the other, and each completes one orbit and one rotation in the same 6.4 days. The New Horizons flyby of the Pluto-Charon system in July 2015 revealed that Charon has a remarkable geological history of its own. Its surface shows a large canyon system, Argo Chasma, up to 9 kilometers deep and extending for hundreds of kilometers across the moon, comparable in scale to the Valles Marineris on Mars. Charon's northern polar region is dark red, colored by reddish organic molecules called tholins that are thought to have been produced from methane gas that escaped from Pluto's atmosphere and was captured and chemically altered on Charon's cold polar surface. Phobos and Deimos, the two moons of Mars, are among the smallest moons in the solar system and among the most enigmatic. Phobos is approximately 27 kilometers in its longest dimension and orbits Mars at only 6,000 kilometers, so close that it completes its orbit in just 7 hours and 39 minutes, far faster than Mars rotates. From the Martian surface, Phobos appears to rise in the west and set in the east twice a day. Like Io, Phobos is slowly spiraling toward its host planet due to tidal deceleration, and it is expected to cross the Roche limit, the distance at which tidal forces overcome the moon's self-gravity, in about 30 to 50 million years. At that point, it will be tidally disrupted and will form a ring of debris around Mars, gradually raining down onto the Martian surface over millions of years. Phobos has a large crater named Stickney, about 9 kilometers across, nearly half the diameter of Phobos itself. The impact that created Stickney must have come close to shattering Phobos entirely. Radiating from Stickney are a system of linear grooves that extend across much of Phobos' surface, which may be fractures caused by the Stickney impact, or may be produced by rolling boulders ejected from impacts on Mars. The solar system contains more than 200 known moons, orbiting every planet from Mars outward, and even orbiting dwarf planets, asteroids, and Kuiper Belt objects. The irregular satellites, small moons on highly inclined or retrograde orbits at large distances from their host planets, are thought to be captured asteroids or Kuiper Belt objects, snared by the gravity of their planet during the early solar system. Jupiter has more than 90 known moons, including dozens of tiny irregular satellites discovered in the past 2 decades through wide-field survey telescopes. Saturn has more than 140, including the newly discovered very small inner moons. Uranus and Neptune each have more than 20. Every moon is a world. Every moon has a surface shaped by some combination of impacts, volcanism, tectonics, and the chemistry of its particular environment. Every moon has a history, and some of them, Europa and Enceladus, and perhaps Titan and Ganymede, and even Mimas, may harbor liquid water in their interiors, making them candidates for the emergence of life in the most unlikely of places, the dark, cold outer reaches of the solar system, far from the warmth of the sun. Let your breathing be barely audible, slow and complete. The moons are in their orbits right now. Io is erupting. Enceladus is venting water vapor into space. Europa's ocean is dark and deep and liquid beneath its cracked ice shell. Titan's methane rain is falling through orange skies. Triton is creeping slowly toward Neptune, its surface geysers erupting under the meager sunlight 5 billion kilometers from the sun. Charon and Pluto are locked face to face, each always showing the other its full face, a gravitational intimacy that will last until the sun exhausts its fuel. The Apollo missions returned a total of 382 kilograms of lunar rock and soil from 6 different landing sites. These samples have been studied by hundreds of scientists over more than 5 decades, and they continue to yield new findings as analytical techniques improve. The lunar samples established beyond doubt that the Moon and Earth formed from the same isotopic reservoir of material, providing the strongest evidence for the giant impact hypothesis. They revealed the existence of the ancient anorthosite highlands, a crust that floated to the top of the global magma ocean that covered the Moon in its earliest days, and they confirmed that the Moon is geologically dead today, with no significant volcanic or tectonic activity for the past 3 billion years. One of the most scientifically precious Apollo samples is the Genesis rock, collected by Apollo 15 astronauts David Scott and James Irwin in 1971. It is an anorthosite, composed almost entirely of the mineral anorthite, a calcium-rich feldspar that was among the first minerals to crystallize as the lunar magma ocean cooled. The Genesis rock is about 4.1 billion years old, nearly as old as the Moon itself, and represents a fragment of the original primordial crust. Holding a piece of the Genesis rock, one is touching a material that formed less than 500 million years after the formation of the solar system. The Apollo missions also deployed arrays of instruments that continued to operate for years after the astronauts left. The Apollo lunar surface experiment packages, deployed at 5 of the 6 landing sites, included seismometers, heat flow probes, magnetometers, and other instruments. The seismometers detected thousands of moonquakes during their operational lifetimes, revealing that the Moon has an active interior. There are shallow moonquakes in the crust, deep moonquakes in the mantle at depths of 700 to 1200 kilometers, and thermal moonquakes produced by the heating and cooling of the surface rocks as the Moon transitions from lunar day to lunar night. The Apollo retroreflector arrays, corner cube reflectors placed on the lunar surface by Apollo 11, 14, and 15 astronauts, are still operational today. Ground-based observatories routinely fire laser pulses at the retroreflectors and measure the round-trip travel time of the reflected pulses to determine the Moon-Earth distance to millimeter precision. These measurements have confirmed the recession of the Moon at 3.8 centimeters per year, measured the shape of the Earth-Moon system's gravitational interaction with unprecedented precision, and tested general relativity to high accuracy. Lunar swirls are among the most mysterious features on the Moon's surface. They are bright, curved markings found at several locations on both the near and far side of the Moon, often associated with regions of anomalously strong remnant magnetic field. The most famous is Reiner Gamma in Oceanus Procellarum, a swirling, tadpole-shaped bright marking about 70 kilometers across, with no obvious topographic feature associated with it. The magnetic field at Reiner Gamma partially deflects the solar wind, creating a miniature magnetosphere that protects the surface from implantation of dark-colored, hydrogen-bearing solar wind particles, keeping the protected region brighter than the surrounding terrain that has been darkened by solar wind bombardment. Water ice on the Moon was long suspected on theoretical grounds. Permanently shadowed craters near the lunar poles never receive sunlight and remain at temperatures as low as minus 240 degrees Celsius, cold enough to trap water ice delivered by comets and asteroids over billions of years. The confirmation came in stages. The Chandrayaan-1 spacecraft detected spectral signatures of water in the polar regions in 2009, and the L-Cross mission later that year deliberately crashed into the South Polar crater Cabeus and detected water vapor and ice in the debris plume. Subsequent missions have confirmed the presence of water ice in substantial quantities at both lunar poles. This ice represents both a scientific resource and a potential practical one. Future lunar exploration could use polar water ice as a source of drinking water, oxygen, and hydrogen fuel. The surface of Europa, as imaged by Galileo and later by Hubble, shows several terrain types beyond the background planes of fractured ice. Chaos terrain, regions where the background matrix ice has been disrupted into irregular rafts and blocks of ice that have rotated and moved relative to each other before refreezing, suggests that the ice shell was thin enough in the recent past for the underlying ocean to have had a direct influence on the surface. The chaos terrain may be sites where warm water from below partially melted the ice shell, allowing blocks of surface ice to move freely before the water refroze. Lenticulae, small dome-like or pit-like features about 10 kilometers across scattered across Europa's surface, may be produced by the upwelling of warm ice or brine from the interior through a process similar to salt diapurism on Earth. The organic molecules detected in Enceladus's plumes by the Cassini mass spectrometer are the most direct evidence yet for complex prebiotic chemistry in an ocean world beyond Earth. The 2017 detection of molecular hydrogen in the plumes, combined with the earlier detection of carbon dioxide, methane, and complex organics, provides a complete picture consistent with active hydrothermal chemistry on Enceladus's ocean floor, hot water reacting with rock, producing hydrogen, carbon dioxide, and dissolved minerals that support complex organic synthesis. In the language of astrobiology, Enceladus may have all three requirements for life: liquid water, chemical energy, and the organic building blocks of biochemistry. The Jupiter Icy Moons Explorer, JUICE, launched by the European Space Agency in April 2023, is on its way to the Jupiter system with the goal of studying Ganymede in unprecedented detail. JUICE will arrive at Jupiter in 2031 and will spend several years studying Europa, Callisto, and Ganymede before entering orbit around Ganymede itself in 2034, becoming the first spacecraft to orbit a moon other than our own. JUICE's primary science goals include characterizing Ganymede's subsurface ocean, measuring the three-dimensional structure of the ocean and the ice shell above it, and understanding how Ganymede's unique magnetic field interacts with Jupiter's much larger magnetosphere. NASA's Dragonfly mission, scheduled to launch in 2028, will send a rotorcraft lander to Titan to explore its surface from the air. Unlike previous missions that were limited to a single landing site, Dragonfly will fly from location to location, covering a total of hundreds of kilometers over its planned mission lifetime. Its targets include the Selk impact crater, where an ancient asteroid or comet impact may have created a temporary pool of liquid water in the methane ice, and the Shangri-La Sand Sea, a vast field of organic sand dunes that covers much of Titan's equatorial region. Dragonfly will analyze the organic chemistry of Titan's surface in detail, searching for the chemical precursors of life and measuring the nitrogen isotope ratios that will tell scientists about Titan's atmospheric history. Saturn has a remarkable collection of small inner moons that orbit within or near the ring system. Epimetheus and Janus are two moons that share nearly identical orbits, separated by only about 50 kilometers in orbital radius. Every 4 years, as the inner moon slowly gains on the outer one due to its higher orbital speed, the two approach close enough to exchange orbits. The inner one becomes the outer one, and vice versa. This periodic orbital swap has been confirmed from Cassini observations and is one of the most unusual orbital behaviors known in the solar system. Pan and Daphnis are small shepherd moons that orbit within gaps in Saturn's rings. Pan, a moon only about 35 kilometers across, maintains the Encke gap in Saturn's A-ring through its gravitational influence, clearing the material from its orbital path and sending characteristic bending waves into the ring material on either side. Daphnis, even smaller at about 8 kilometers, similarly maintains the Keeler gap. Cassini images of these moons reveal that they have unusual shapes with prominent equatorial ridges, thought to be caused by ring material accumulating along their equators as they orbit within the ring plane. The shepherd moons of Uranus, Cordelia and Ophelia, confine Uranus's narrow, dark epsilon ring between them. Through a gravitational mechanism, they orbit just inside and just outside the ring, and their gravitational nudges prevent the ring particles from spreading. Without these shepherd moons, the epsilon ring would diffuse outward over timescales of thousands to millions of years. The rings of Uranus are very different from Saturn's. They are narrow, dark, and composed of very dark material rather than bright ice, suggesting that their particles have been darkened by radiation over time. Within Saturn's main rings, there exists a hidden population of tiny moonlets, objects tens to hundreds of meters in size, that are embedded within the ring material and too small to be imaged directly, but detectable through their influence on the surrounding ring material. Cassini detected dozens of these moonlets within the B-ring through the propeller-shaped disturbances they create in the ring material around them. Each propeller consists of 2 arcs of depleted and enhanced ring density extending from either side of the moonlet in its direction of motion, like the wake of a small boat. These propeller moonlets are the missing link between ring particles and full-sized shepherd moons. Let your body settle into complete stillness. The moons of the solar system are orbiting right now in the dark and the cold, the volcanic ones and the icy ones, and the two-toned ones, and the tidally heated ones, and the tidally disrupted ones, and the chaotically tumbling ones. Each one is unique. Each one is a separate experiment in planetary geology and chemistry and orbital dynamics, and some of them, in their dark interior oceans, may be experiments in biology as well. And our own moon is rising or setting somewhere in the sky above you, reflecting the same sunlight that illuminates all these other moons. Its ancient dark seas still and quiet. The Sea of Tranquility, exactly as it was when it formed 3 billion years ago, exactly as it was when 2 human beings first stood in its dust, exactly as it will be for billions of years to come. The moons of the solar system are witnesses to time on scales that dwarf human history. They have been orbiting their planets since the solar system was young. They have seen the bombardment that cratered their surfaces, the volcanism that built new terrain, the tidal heating that melted their interiors, and the slow, patient cooling that has been ongoing ever since. They do not hurry. They do not change their courses. They simply orbit in the dark and the cold, year after year, millennium after millennium. Their ancient faces turn toward their planets, and their darkness turned toward the stars. Tonight, rest in the quiet certainty of their orbits. The moon is there. The moons of Jupiter and Saturn are there. The extraordinary worlds of the outer solar system are there. All of it is patient and present and extraordinarily ancient. And you are here on the most explored of all the inner worlds, drifting gently toward sleep in the faint reflected light of a moon that has been keeping watch for longer than any living thing on Earth. Before you sleep, consider one last fact about moons. On the night of January 7th, 1610, the Italian astronomer Galileo Galilei pointed his newly improved telescope at Jupiter and noticed 3 small bright points of light near the planet arranged in a line. Over the following nights, he observed that the points moved, changing their positions from night to night. He recognized that they were not background stars, but objects orbiting Jupiter. Over the course of a week, he discovered a 4th point of light. He had discovered the 4 largest moons of Jupiter: Io, Europa, Ganymede, and Callisto. This discovery was among the most consequential astronomical observations ever made. It demonstrated for the first time that not all celestial bodies orbit the Earth. Here were 4 objects clearly orbiting another planet. The geocentric model of the universe, in which the Earth was the center around which everything moved, could not accommodate objects orbiting Jupiter. Galileo's discovery provided direct observational evidence for the heliocentric model of the solar system and contributed substantially to the revolution in cosmology that transformed humanity's understanding of its place in the universe. The 4 Galilean moons are named after figures from the mythology of Jupiter, Io, the lover of Zeus; Europa, also a lover of Zeus; Ganymede, a youth abducted by Zeus; and Callisto, a nymph loved by Zeus. This tradition of naming moons after mythological figures associated with their planet's namesake continues today. The moons of Saturn are named after Titans and other figures from Greek mythology. The moons of Uranus after characters from Shakespeare and Alexander Pope, and the moons of Neptune after figures from Greek sea mythology. This tradition connects the names of the most distant and alien worlds in the solar system to the deepest roots of human storytelling. The moon has shaped human culture, timekeeping, and even language for the entirety of recorded history. The word month derives from moon in Germanic languages. Calendar systems around the world have been based on the lunar cycle. The Islamic calendar is purely lunar, with months following the phases of the moon exactly. The Hebrew calendar is a lunisolar calendar that aligns months with the moon and years with the sun. The full moon has been a communal gathering point for human cultures throughout history, a reliable light source that made nighttime activities possible before artificial illumination. The moon is visible to the naked eye in sufficient detail to see the dark Maria and the bright highlands that ancient observers named after terrestrial features, seas, mountains, bays, marshes. Every human civilization that has ever existed has looked at the same moon, seen the same dark and light patches, and told stories about what they saw. The face in the moon, the man in the moon, the rabbit in the moon seen in East Asian traditions, all are different interpretations of the same pattern of Maria and highlands that has been unchanged throughout all of human history. The Sea of Tranquility that opens this story is also a state of mind. It is the quality of a night where the universe is not threatening but simply present, vast and ancient and indifferent in the most benign sense, operating according to laws that do not require your attention or your anxiety. The moons of the solar system will orbit their planets regardless of what you are worrying about. Io will erupt. Enceladus will vent its plumes. Titan's methane rain will fall. All of it is happening right now, at this very moment, as your breathing slows and your thoughts grow quiet and the darkness of a natural night settles around you. The universe is very old. The solar system is very old. The moons are very old. And you, brief and warm and briefly awake, are about to join the long, quiet majority of your own life that is spent in sleep, in the dark, and the restoration that makes the waking hours possible. Rest now. The moons are in their orbits. The seas of the moon are still and ancient and perfectly tranquil. Let their stillness be yours. And if you wake in the night and the moon is shining through a gap in the curtains, know that its light left the sun 8 minutes ago, crossed 150 million kilometers to the lunar surface, reflected off rocks that have not moved in 3 billion years, crossed another 380,000 kilometers through the vacuum of space, passed through the thin miracle of Earth's atmosphere, and arrived at exactly the window of exactly the room where you are lying, warm and still and alive. The universe is absurdly precise in its gift-giving. It sent that photon specifically for you. Tonight you are held in the light of ancient seas, and you are safe. Good night. Sleep deeply. The moons are keeping their ancient vigil above you,